Hi students, welcome back to Study Smart channel. Today we are covering part 2 of chapter 5, Solution and Rate of Solubility. Let's start. First of all, we need to know what is solute, solvent and solution. Solute is referring to a substance that can dissolve in a solvent. Can you think of an example of solute in your daily life? Yes, sugar and coffee powder are types of solute that we encounter on daily basis. They can easily dissolve in your morning cup of coffee. Now, moving on to solvent, it is the liquid that dissolves the solute. So, in your cup of coffee, can you figure out the solvent in it? Yes, hot water is the solvent. Lastly, your coffee is the solution that consists of the mixture of sugar and coffee as solutes that dissolve in the solvent, which is the hot water. Here is an example diagram that shows the solute, solvent and solution. So, in your cup of coffee, the solute will be the coffee powder and sugar, solvent will be the hot water and solution is the coffee itself. Now, moving on to the type of solution. We have two types of solution, dilute solution and concentrated solution. Dilute solution referring to a little bit of solute inside the solvent, while concentrated solution refer to a lot of solute inside the solvent. There is another one type of solution known as saturated solution. Do you know what is meant by saturated solution? Saturated solution is the solution that consists of maximum amount of solute and cannot dissolve any more of the solute that is added to it. So, if we add more and more solute to a saturated solution, the solute will start to sink at the bottom of your cup. Now, let's see the factors that influence solubility rate of substance. We have three factors. The first one is the temperature of solvent, size of solute and rate of stirring. So, in order for us to increase the rate of solubility of substance, we need to increase the temperature of the solvent, which is the cup of the water. And we need to decrease the size of solute, which means that you need to use a finer sugar or salt solution. And finally, we need to increase the rate of stirring in order to increase the rate of solubility of substances. Now, we want to see the definition of suspension and colloidal solution. Suspension is defined as a mixture that contains insoluble substances that can separate over time. For example, we have muddy water. Muddy water, if we left it over time, you can see that the mud will sink at the bottom of the cup while the water is at the top of the cup. Second, we have an example of flour in water. And then we have example of juices that can separate over time. This is all considered as a suspension. Okay students, now is the time for smart question. My question for you is, if suspension is defined as a mixture that contains insoluble substances that can separate over time, is oil and water will be considered as a suspension? Think about this and I will let you know the answer at the end of this video. Moving on to colloidal solution. Colloidal solution is defined as a mixture of two or more solutes dispersed evenly in the solvent. They do not combine. Example of colloidal solution will be yogurt and milk. In yogurt and milk, the protein and fat globules disperse in a liquid. They do not dissolve in the solvent. Another example of colloidal is considered as the smoke in the air. The smoke will be dispersed evenly in the air but do not combine with the air. And the last example of colloidal solution will be gelatin. In a gelatin, the water disperses in a protein medium. Alright, by now you know that water is a type of solvent. But do you know that water acts as a universal solvent? Yes, this is because water is able to dissolve almost all the substance such as solid, liquid and gas. It is used in many chemical reactions in our body and also to transport substances in our body. Other than that, water also can dissolve cleaning agents such as dishwasher liquid, soap powder and toilet cleaner. This is why water known as a universal solvent. But there are still got some substances that cannot be dissolved by water. So how we supposed to dissolve those substances? Here comes the organic solvent. Organic solvent are special liquids that can dissolve all sort of stuff that water cannot. They are like the superhero of chemistry. They can dissolve things like oils, fat and waxes, making them super handy in labs and everyday life. The first example of organic solvent we have is ether. Ether can dissolve oils, fat and grease. Normally, ether will be used in the production of cosmetic products. Second organic solvent that we have is turpentine. Turpentine is used to dissolve paints, tar and grease. Turpentine normally used to dissolve paint for easier usage. Next, we have chloroform. Chloroform can dissolve plastics. They used to stick plastic substances. The last organic solvent that we have is benzene. Benzene can dissolve rubber and also grease. They are used to stick rubber sheets. In summary, we have organic solvent that can come handy for dissolved substances that water cannot dissolve. Those organic solvents are ether, turpentine, chloroform and benzene. Alright students, we're done with the topic today. So now coming back to our smart question just now. My question to you was, is oil and water is considered as a suspension? Well, the answer is no, they are not considered as a suspension. They are considered as an emulsion. They are not considered as a suspension because if you see the definition of suspension, it is a mixture that contains insoluble substance that can separate over time. It is a mixture, that's the keyword. Oil and water is never a mixture. They cannot mix with each other. So, the answer for this smart question is no, oil and water is not considered as a suspension. Alright students, we have came to the end of this video. That's all from me today. So thank you and have a nice day. Bye.